Equation for progressive wave. Suppose a progressive wave, you use the term progressive wave itself confirms that the medium is free and the wave has no restriction on the propagation. Suppose this wave is proceeding along x-axis, and just suppose it is transverse wave, obviously the particles will be oscillating along y-axis. Then this wave could be represented by the equation a sine omega t minus kx plus phi. You see, A would be called amplitude. Here, when I'm using the term sine here minus, it means the wave is propagating along plus x axis. Omega t minus kx plus phi, this as a whole would be known as phase. That is called the phase of the particle in oscillation. You are already aware of the terms omega k. Omega is known as angular frequency or angular velocity. K is known as propagation vector. This is also given by 2 pi by lambda. You know, wave number is another term, number of waves per unit length, that is known as 1 by lambda. This is called wave number. Suppose the wave is proceeding along negative x-axis. In that case, you will use the term A sine omega t plus kx plus phi. Now you see, you might ask me if this whole bracketed quantity is termed here as a phase, then what is the special name for this phi? You see, you start with, that means you take origin, x will be 0. You take the starting situation or starting point, t will be 0. In that case, if these two become 0, what phase remains is only phi. So this phi is also known as initial phase. Phi is also known as initial phase. That is also technically known as epoch. So phi alone will be known as initial phase, whereas this whole term will be known as phase. Then if there is phase, obviously you will come across phase difference also. You see, phase difference could be given in two ways. One method is in terms of path difference. Phase difference, phase is angle, and SI unit for angle is, radian. So this will be measured in radian, and here delta x is path difference. That will be measured in meter. Lambda already is in wavelength. Lambda is wavelength, that will be measured in meter. Similarly, this phase difference is also measured in terms of time interval, that is delta t. Here capital T will be time period, and again its phase difference. This will be measured in radian, this in second, this in second. One point is also of much interest and importance for you, that how the phase changes. You see, we are preparing ourselves for the study of stationary waves, which is possible only by the superposition of two waves, incoming incident progressive wave and out reflected returning, that will also be progressive wave, but that will be returning. So when superposition of two waves moving in opposite direction will take place, stationary waves are going to be produced. So what happens when the wave is reflected? This is also a point of interest. You see, if it is a free medium, free boundary, if the reflection is from free boundary, then no phase difference takes place as it is shown over here. No phase difference is taking place. It is returning in the same phase. If the boundary that is reflecting the wave is rigid, then in that case the phase difference of 180 degree will be produced, and this is shown over here. Here the trough and crest, they are interchanged. If the crest has striken a surface, it is going to return as a trough, means 180 degree phase difference is taking place. Kinetic energy and potential energy in a stationary wave, these will continually interchange into each other, and when the progressive waves are getting traveled or they are propagating, then energy transport per unit time, or you might say the average power, is given by half mu omega square a square v. Here mu is the mass per unit length, which is also referred to sometimes as linear density.